Hello everyone, welcome again for webinar on MIDAS Engine Software Solution. In today's webinar session, we are going to look at the modeling to drawing of combined RC and steel building as per Eurocode. My name is Nivedita Khole and I'm the Technical Support Engineer in MIDAS IT. Now let us begin with the introduction to MIDAS Engine Software Solution. We will look at some of the strengths related to today's sessions in the demonstration of MIDAS Engine. However, before we go ahead to the introduction to MIDAS Engine, I'd like to talk about some family programs that MIDAS offers. In terms of bridges, we have MIDAS Civil and MIDAS FES software solution. MIDAS Civil is an integrated solution system for bridges and civil structures. You can perform the analysis and design of simple bridges like box culverts, frame bridges, slab bridges, to steel composite, PSC composite, to high-end bridges like suspension bridges, cable stayed bridges, and so on. Coming to the structural family programs, we have MIDAS Engine software solution, which can perform the analysis and design of steel as well as RC structures. The design from MIDAS Engine can be taken into MIDAS Drawing software solution to generate the drawings, rebar detailing, and bill of materials. We also have got a component software solution that is MIDAS Design Plus that can perform the design and tell us or give us the output in the form of Word file, as well as it can give us the drawings and also bill of material. That's about structural solutions. Coming to the geotechnical, we have GTS-NX, which is our 3D geotechnical software, and SoilWorks is our 2D geotechnical software solution, a very user-friendly software for practical design. Coming to the mechanical field, we have MIDAS NFX and MIDAS FX Plus. Now let's move ahead to the introduction to MIDAS Engine. MIDAS Engine is our next generation solution for building analysis and design. So what does our MIDAS Engine software comprise of? MIDAS Engine comprises of analysis tool, design tool, and drafting tool. So you do not need 3 separate software solutions for the entire project to get completed. So we can use just MIDAS Engine to finish our procedure to analyze, design, and draft our project. Let's look into the design standards available in MIDAS Engine software. For wind loads, we have European and British standard. For the seismic loads, we have European standard. Steel design can be performed as per European as well as British standard, and RC design can also be performed as per European and British standard. All right, so that is about the design standards. Now, MIDAS Engine is also integrated with other software solutions like BIM tools. We can take the model files from BIM tools into MIDAS Engine, and if there are any modifications in the model, then we can take it back to the BIM tool. Then further, the design results of MIDAS Engine can be taken out in the form of DWG or DXF files, which can be used in MIDAS Drawing, MIDAS iCAD, or the most famous Autodesk AutoCAD. MIDAS engine is an all-in-one design system that can begin from the architectural drawings and provide the output in the form of structural drawings. So it is from drawing to drawing, we can perform the modeling, analysis, design, reports, and quantity takeoffs. Let's look at its all-in-one design system in a demonstration wherein we will look how the modeling, analysis, design, reports, and quantity takeoffs can be integrated in one software solution. We'll look at some of the automated features, and we'll look how the program can perform optimization, and further we'll look at the high quality outputs generated by MIDAS engine. So without any further delay, let us go to MIDAS engine software solution. So this is the structure that we are going to be looking at today, wherein we are going to consider the steel structure at the top of an RC building. Basically demonstrating how we can have both RC as well as steel in one software solution. And we can analyze as well as design both of them at once. So I'll start with the most easiest modeling method, that is our 3D grid line method. Here I'll be having 4 numbers at 6 meter spacing in the X direction. And here I'll have 5 numbers of spacings at 5 meters. And then our levels. So I will have, let's keep it as 4 meter itself as the level. And further above, this height will be 3 meters. Let's say that the floor to floor height is 3 meters. And about that, we have got a height of another 4 meters for our steel structure. So I'll click on apply over here and press escape to get out of the command. And then we will go to the convert into members command to generate our beam and column members. So here I'm just going to select part of the structure for converting into members. Firstly, I'll make my RC members because I'll start from the bottom. Then the column members. And after that, I will go ahead to some steel columns. So I'll use UC 305 and I'll select all of these and apply. So this is how I've basically created my steel columns over the RC structure. So I'll press spacebar again to come back to the same command, wherein I'll create my steel beams at the top. So I'm using again I'll use UB 305 and I'll just create these beams right at the top. So we have got over here RC and steel members. Let's create some more members by going to the member tab. Let's start with slab. So let's select all our periphery beams to create the slabs for our RC building. So I'll click on apply. So we have got our slabs for our RC building. Now let us create a truss at the top of our steel members, like beam members, beam and column members. And for that, I'm going to use the import command. So basically, I've created my truss in a DXF file, and I'm going to import my DXF file to create my truss. We can model ourselves the truss over here in MIDAS engine itself, but it'll be faster if I go ahead with just importing the DXF file. So there's a steel truss center line that I'm going to utilize. And the unit system is meter for my DXF file and my engine file. So I'm going to have scale factor of 1. And then I can put my truss, which is right now at the bottom. I'll put it at the top wherever I need the location. Okay, so I'm going to place it right at the top. And after that, I can decide to convert, or I can decide to basically create directly the members or use this information in the form of body lines. So I'm using this information in the form of body lines. I've sketched my truss, and now I will right click and hide all my members as well as my grid line. I'm going to work on my body lines right now. So it's like a sketch. It is not going to be utilized for the analysis. It will be utilized for the modeling as well as loading purpose. Here I'm using my body lines for the modeling purpose. So I'm going to convert my body lines into members. It's a very easy feature. You just have to select the lines, select the type of member they should be, and then click on OK or apply. So same thing I will do by selecting polygonal, using polygonal selection, selecting all these upper chord members. And I've selected beam member type. Property is C-section, and I click on plus, that is apply. And then I'm going to create truss members. So I'll get back to my rectangular selection and select all these inclined lines and convert them into brace type of members. In brace as well, we have got different element types. So we have truss element, beam element, tension only element, and compression only element as well. So I'm using truss type of element and angle section, which is by default available in MIDAS engine, new file. You can of course create your own section properties. In the first 2-3 sessions, we have seen how to create these section properties. And so I would not be repeating the same as such, but just to let you know that we can change by right clicking and saying modify, or you can just right click on the section and add one more section to be applied on the structure, to the structure. So I'll unhide all the members, and I'll copy this truss on the remaining parts or the remaining columns. So here I'm going to use my copy command, copy member command. I'll select all my truss members, and I will use this select by 2 points command. And from here, I can directly just click from, provide the distance by just clicking on the location where I want a particular or that particular member to be copied. So this is done, and now I can go ahead to create my purlins. So to create the purlins, I'm going to use the C section itself, but of course we can use the Z section. However, the Z section will not get designed. So if you don't want your purlins to be designed, you can definitely assign Z sections. If not, then you can apply them as C sections itself, like I'm doing over here. Okay, so same thing, I'll be doing it on the other side. Okay, so just click on the first and last point, right click to come out of the command, space bar to get back into the same command. And whenever we are snapping, we have to take care that there is a cross mark so that the nodal connectivity is maintained. So it's like a snapping tool that we have, just like in CAD softwares, we have snapping tools. So similarly, we have snapping tools. Now these purlins, they are at the moment offsetted as center top, but we can change it to center bottom to make them look like they are above our top chords. So I'll just change their offset point as center bottom. And further, if we look closely, we can also provide some angles to them. So before we do that, I would like to also modify this elevation. So I'll make these beams as center top. Okay, so we have a clear view of our purlins. And if there is any modification, like any angle to be provided for the purlins, that can also be done. So for example, I would like to change the angle of these purlins. So you can see over here in the properties tab, there is a rotation option. So this is somewhat 19. Okay, that would be negative 19. So this is going to be minus 19 likewise. That's how we have assigned, and this would be positive 19. Okay, so this is how easily we can do the rotation of our members. It could be not just the purlins, but any column can be rotated, any beam can be rotated, and so on. So we are done with all our members. One more thing is remaining, that is the connection between the column, our steel column, and the RC column. So usually we consider pin type of connection between the steel and RC column. So over here, how we can do that? Simple, we have to provide beam and release. So in the boundary tab, we have beam and release command, wherein we can specify if any end has to transfer the moments or not. So I'm selecting all these columns, steel columns, and I'll use fixed pin type of condition. I can check over here if it is correct, like before application. And then after that, we'll click on OK. All right. So it's basically going to assign pinned condition at the bottom according to the figure. Now, if you're not so sure as well, you can actually check the member axis. So as per the member axis, you can see that it's supposed to be pinned fixed, or you can even make it pinned pin type of connection. So I'll just undo the beam and release, and I'll make it as pinned fixed, since all of our columns were created at the same time, so they'll have the same type of axis, local axis. And now we can see that there is a red circle at the connection between the steel column and the RC column. So we can understand basically if anywhere a beam and release has been applied. Okay, so same thing can be done if you are considering the connections between the elements as pinned. All right, so after this is done, we'll move ahead to the next part, and that is the load application. So here we are going to assign the dead loads, the live loads, and the wind loads. Okay, one more thing is remaining, and that is the foundation. So let's create foundation, but before that, we'll define some stories. So let's add the story, and we'll auto-generate the story data by considering all. And over here, there are several stories that the program has automatically detected. It's because it detects at every point which is at different level. Okay, so we can understand from this front view, and by checking on this, on this option to show the floor heights, we can remove the data for 9F, 8F, and the 7F. So that is our choice. If we want to remove that information, we can. It is not going to affect the analysis as such, but this is just for the information for drawing and for the wind load application. So if you want, you can definitely keep it, or you can remove it. All right, so I'm going to be like removing over here only the story data. Okay, so here we have all these levels ready with us. Now I'll go to the story on the 1F level. I'll draw my isolated footings. So these isolated footings, I'm considering having the length breadth of 4 meters, and I will just select all the columns at once and click on apply. So we have got our isolated foundation, isolated footing, but the thickness property has to be again defined for our footings. So that I'm considering as 500 mm, and I'll click on OK. I'll select all my footings over here and assign it 500 depth. All right, let's get back to our 3D mode, and we will move ahead now for the next part. Yeah, that was loading. Apologies, let me quit the Skype. Okay, so self weight will be applied, and that will be under the dead load set. So we are defining dead load and live load sets right now. So under the dead loads, self weight is assigned. Now let's assign the dead loads and live loads for our RC slabs, and that will be done using the slab load. So let's create a slab load type wherein the dead load and the live load will be applied at once. This is in Newton per meter square. So we can change the unit system and then create the slab load type, or we can create the slab load type considering the unit system which is already there. So here I'm going to provide a dead load of 1500 Newton per meter square and a live load of 2000 Newton per meter square. I'll add it and close, and then I'll assign it to all my slabs. Now, when it comes to the steel roof, where we have not modeled our slab as such, we can use the floor load command. So there is a floor load command available, in which again we have got the load type, floor load type, wherein dead loads and live loads can be assigned at once. So here I'm going to be considering the dead load of the roofing, which I'm assuming as 130 Newton per meter square, and the live load I'm considering as 750 Newton per meter square. So I've assigned the dead loads and live loads in the floor load type. Now I'll assign a load distribution. So we want one-way type of load distribution of the roof, wherein the load will be transferred on the purlins. So for that, I'm going to activate only my roof to make it easy for application of loads, floor loads. And then let's add an area on which these floor loads are to be created. Now, usually we need sometimes dummy beams, or we need to create groups and all to assign the floor loads on inclined plane. Here, that's not required. You just have to provide the periphery points and click on apply. So we forgot to provide negative sign for the loads. That's why we are seeing the downward information. Let's modify that part. We will just go back to the floor load type and provide a negative sign over here and click on modify and close. All right, so this is done. Now we are going to be creating the other side information as well. So here I'm going to start from the shorter edge so that the loads will be assigned on the longer edge. So here I'm going to click on apply first of all to assign to the first, and then floor load will be assigned on the other side. So I'll click on add. Okay, so basically we are assigning the floor loads on this structure. So let me close this, activate the entire structure here. All right, and if we are actually good at snapping on correctly, we can assign the floor loads as well directly by using the 3D mode. So we don't need to be in any kind of mode as such to assign any self-weight or floor load. So let me over here show how we can do that. Just cross signs should be utilized for the snapping. And then you click on apply. Okay, so let us try that again later. All right, so basically we have assigned the floor loads, roof load over here on one side, and we'll be assigning the roof load on the other side. If at all you do not want to use the floor load command, you can still create the plate type of members. Like for example, over here, I'm going to select from the front view these lines and these lines as well. So these are selected, and plus I'll select these periphery ones. And then the roof will be generated in this way. So you can provide a thickness to it, and then that load will be automatically considered. So here you can just change the thickness of, let's say, the thickness is with the proper material property. You can provide, let's say, a 3 mm thickness. Likewise, and select the roof and add, sorry, I'll just modify it. It's supposed to be 0.03. Okay, and then drag and drop. So this is how you can basically assign. And further, you can get it cut with respect to the purlins, and that can be done by using the divide command. So here we have got the divide command, wherein the tool can be utilized by selecting the 2D members in the 3D mode. If you're going for plane, then you can use the line elements. So if I go for this plane, then I can use my divide command with a tool of this one. So I can apply this. Then secondly, I can use a tool for cutting with respect to this line, and same thing with respect to this line. Okay, so this is how I have assigned the roofing, and this also I can apply it. I can assign a proper material property to it, and it can be utilized for the analysis purpose as well. But if you want to make it only to assign the loads on these particular elements, then all we have to do is basically connect them to these elements on which the load is to be applied. So I'll get back to the 3D mode, and I'll hide all the reference and hide all the labels. So this is how we have created our entire structure. If we do not want to use it, then we can go always ahead with the floor load command. Okay, so the next part is about the wind load. We'll go to assign wind load command, and we have the option for enclosed area, open area, and equipment type, as well as story-based type of structures. We have already created stories, so let us assign wind load as per the European standard. The story shear and the story forces as per the wind loads will be automatically calculated by the program. All we have to do is click on OK. So after this load has been applied, we'll move ahead to the boundary conditions, wherein soil support will be assigned to our foundations. So we will add a soil spring support based on Joseph Ball's equations. I'm considering 230. Okay, this is a Newton per meter square, so 230,000 Newton per meter square. And we will assign this to the foundation members. Okay, let me change back the unit system to kilonewton meter for easy understanding. All right, so here we go. We are done with all these members like steel as well as RC and foundation. Next part I would like to talk about is rigid region, which can be assigned to our columns connected to our mat foundation. So here, or mat foundation or isolated footing, both options are there. So I'm going to select all these columns and assign rigid zone to it, and I'll click on OK. Now, when I mentioned about optimization that is available in MIDAS engine, we have over here auto generation command wherein beam and offsets and rigid zones will be automatically taken or considered by the program. So if you remember, for each type of member, there is an offset point provided, center top, center bottom, and so on. So all of these would be considered after we generate them. Now everything is considered. We'll go ahead for the analysis. We'll create one analysis case. If you want, you can create multiple analysis cases, one with the foundation, one without the foundation, one with only the steel structure, one with only the RC structure, and so on. I'm creating an entire structural analysis, and I'll run it right now. I'll save the steel structure. The analysis is now taking place. And within few seconds, the analysis is completed. Now we will move ahead to the next part. And that is looking at the results. So here we have displacement. Let's look at the displacement in the form of mm. So maximum displacement is 5 mm. That is only with respect to the dead loads. We can create our load combination as well. So let's auto generate load combinations for the RC as well as for the steel for the design of both type of members. So we have just simply created automatic load combinations for steel, that is EN 1993, and for RC, that is EN 1992. All right, this load combination will be utilized for the design purpose as well. Now, all I'm going to do is create a design group as well. So I'd auto-generate a design group. And I'll click on OK. So we have created design groups automatically. We can manually also generate the design groups. We have assign design group option. We can define and assign them to selected members. Right, so I was talking about the results in the form of display. So here we have got the results. I'll change the unit system to kilonewton meter. So the subgrade stress is maximum 79.82 for center isolated footings. And we can look at the results separately for the combinations of RC or for steel. So we can actually look at the envelope results. So I'm considering the characteristic minimum results, and the value is 96.51. So that's about the subgrade stress. You can also look at the strength results, envelope results. That's 132.79. Okay, so this is one thing. Now we can also look at the beam forces, like we can look at the bending moment diagrams. So we can see over here the bending moment diagram of our beams, and wherever the columns are showing the bending moments, we can look at those results as well. So this is bending moment in the minor direction for the columns. And we can look at the shear forces as well. So this is the shear force, and as we had used a rigid zone, we can see that the location wherein our beams and columns are intersecting is not considered for the design purpose. So that's how we can optimize our design results. Basically, when we are finding the moments at the considering the center to center modeling, then we are getting more moments or higher moments at these locations, the junction locations. So to avoid that, we can use the rigid zone. Okay, so that's one part. Next, we can also look at the truss forces. So we have created truss members. Inclined members in our truss are truss members. And we can look at the axial forces, and if there are any torsional forces, we can see those as well. So torsion is of course not there in our truss. Now we'll move ahead to the next part, that is the design. So in the design, we have created combinations, we have created design groups. Now all we have to do is create a design case considering all the members, and we can consider over here all the load combinations and then click on OK. So both steel and RC are going to get designed at once. So all we have to do is check on this auto rebar arrangement for the RC. In the RC, we have got our beams, we have got columns, we have got isolated footing. Yeah. So we have got all these types of members, and we can control the diameters of bars it will utilize for providing the rebar arrangement. So I'll click on OK after this, and we will see, or we will look at the design. So there are some members which are failing over here, and we can see them while the design is getting performed. For example, in case of the plate elements which we have utilized for the roof, it says that the calculated rebar arrangement exceeds the maximum value. So it is actually trying to also design that roof, which is actually not required, so we can ignore that part. I think it is providing the same information for all the roof plate elements that we had modeled. So you can ignore it, can design cases, you can uncheck the plate elements for the design purpose. Another thing, when we are using plate ends and we do not want to transfer the load on any edge from any edge, then we can use plate end release. That's the command. Yesterday in the water tank session, we had seen how to use that particular command. So by the time the design is taking place, let me consider some of the queries that are here. Okay, the design is performed. Let's look at the design outputs right now. We'll firstly look at the total status. So as expected, the plates are going to be failing. So that's the failure. And other than that, we can see red marks as well. Members marked in red color. Those have failed. And we can then further find out why they have failed, if they have failed for strength or they have failed in the serviceability conditions. So when it comes to serviceability conditions, you can see some of the columns are failing, and they are probably due to the stress. So we can see over here the stress is going beyond 1 is 1.35, and that's why they're failing. So that's one point. And let's look at the status for the strength check. The actual ratio is fine. Bending ratio is 1.1. So for some slabs and for some foundations, we are experiencing value greater than 0.9. So most of them are greater than 0.9 and less than 1.01. This is how we can understand from the legend. Then some failures are because of the shear. So shear failure, of course, we're expecting shear failure for our plate elements. It was having hardly any stiffness. And if I am activating only the RC structure, so you can look at the results only for the RC structure right over here and check the results separately by activating them only. So there are foundations, isolated footings, for which the shear failure has taken place, and punching failure is not there, just the shear failure when shear failure is observed. So that's one part. Deflection ratio also is checked. So it is fine for our members, RC members. We can check separately for our steel members. So just say show only, and we can check over here. So for serviceability, check stress ratio is deflection ratio is satisfied for our steel members. Now let's move ahead to the output in the form of reports. So you can actually look at the output for the steel structures, steel beams, steel columns, and also for the truss. So I'll click on OK. This is for the steel member. It's a beam where the fatigue check is there, deflection check is there, shear check and moment check is there, combined shear and axial and moment check is there. Then this is our column. No, this is our bigger beam actually, and same thing is available. This is our column. Again, deflection and fatigue check is there. This is our brace member. So for the brace member as well, we have got deflection and fatigue check. Okay, so this is how we can get the summarized output of steel members. And similarly, we can get a detailed calculation report for our steel as well as for our RC members. So if I click on OK, you can see a file by program which contains all the formulae required So we can actually check how the program has performed the design, or checked in case of steel, it is going to check for the limits. The resistance is calculated using the formulae provided in this detailed calculation sheet. So this is about the detailed design report provided for the steel as well as for the RC structures. Let's move ahead to the reports and the drawings. So we can actually generate a report from a report maker. In this report maker, you can actually input the items that you want to use for creating a project report. You can provide the steel member list for the columns, for the beams, braces, and the slab, RC slab member list. And further, you can go ahead for showing off the analysis model, the final analysis model. Then you can also input the information for the wind load. So here we have wind load story shear profile that can also be included. Then if any applied loads are to be taken out as an output, you can still take it from here. Then the boundary conditions that were assigned. So you can provide the information for the point springs that were assigned. And then further, we have the information for our design. So we have total result for the steel and for the RC design. Now, after you provide all the information in the report generation, then you just click on generate right over here, and the entire project report will get generated. You can have a full control over what all information is getting generated in MIDAS report maker. So here we have the cover page, then the list of the steel columns, steel beams, and brace list and RC slab information, RC slab list, and the reinforcement arrangement as well. The analysis model, then the point spring information, and here we have the output. This is for the RC output generated by the program, where it tells the section size, the design ratio, and the status, if it's okay or not good. Now, if in case you have got any modifications in the model file, you can do those and without any problem. And when it comes to report maker, you just have to check and update and then generate the entire project report again. So with one click, the entire project report can be regenerated for any modifications made in the model file. Okay, so this is done, and now we will move ahead to the drawings that are generated. So let's go to the settings and let us auto-generate all the information as per our model file, wherein the foundation plan, the rebar arrangement for the slabs is mentioned, and then we'll modify it for the drawing set that is going to be utilized for our drawings. We'll click on OK, and after that, save this information and then generate the drawings. MIDAS drawing software solution has got similar features as 2D CAD software solution. You can draw by yourself in this software solution. You can do modifications. You can even use all the shortcut tools available for any CAD software. So here I'm going to start generating the structural design overview, wherein the information for the codes utilized for the steel design and RC design and wind load as well. You can see over here the material properties utilized and the type of members and their rebar diameters and the grade of rebar used. Then further structural plans can be generated, like floor plan. So I'll generate the bottommost and the first floor plan. At the beginning, the program is going to take all the information and it is going to generate it from inside, and later on, whichever plan we want, we can very quickly get it drawn in MIDAS engine. Okay, there are several questions actually. I think I'll be answering them in the last 5 minutes. All right, so the drawing is going to get generated after we can see a box. We place that box basically on the workspace of MIDAS drawing. By 2 clicks, we are specifying the location of a framing plan and the distance between 2 framing plans. So we get over here the framing plan of ground floor with all the isolated footing information, and then the first floor typical plan, I would say. And after that, we can also generate some sections. So structural sections can be generated. So in this way, we can generate the sections. So to get the bracings, we will use generate structural section using axis offset. So I'll use this axis offset and create the sections from here. So we get our braces information, the center line of braces, and we are able to see the information for all the types of steel members. Anyway, we get a list as well of the section properties or section shapes that we have utilized for all the types of members. Then let's look at the drawing of reinforcement slab. And let us also take a look at the foundation plan. So within minutes, we're able to generate the entire structural drawings. Okay, so this is for the slab. The reinforcement arrangement is specified. And over here, this is for the isolated footing, where the reinforcement is specified. Top and bottom reinforcement. And also we can generate the rebar arrangements for our beams, columns, and shear walls. I have not modeled shear walls in this model file, but I think in the first session we have seen how that information can be extracted in the form of drawings. So we have got reinforcement arrangement for the top and for the bottom. We have the stirrup arrangement as well. As you can see, the stirrup spacing varies throughout the length of the beam. So this is required to be captured, and so it is specifying in the form of lines. And we can also see the cross-section information for each part of our beam member. We get a key plan and we get bar bending schedule as well. And finally, we can also generate the bill of material. Now, when it comes to steel sections, you might also wonder about the connections. So basically, in MIDAS engine, we will be in future having the connection design included. For now, we have MIDAS Design Plus software solution. That's what I would like to show you. This is MIDAS Design Plus software solution, which can perform the design of the bolt connections, base plates, crane girders, and so on. But this is with respect to the American standard. So if I change the code over here to Eurocode, we can see those which are applicable itself. Okay, I think I have to check with my license. Anyway, so basically we have got all these types of members for a separate design. However, all of these which we are able to see right now are as per the American standard. So we will be including the connection design in MIDAS engine itself in the future. Here is the bill of material. And we get separate information for the steel members like the lengths, the quantity, and the total length. Unit weight is in ton per meter. Total weight will be provided in ton, sorry. And perimeter will also be provided, that is in meters. Then surface area, outer surface area or paint area will be also provided. That's one type of Excel sheet output. We get another type of Excel sheet output as well for based on the member and the type of member and the group. This is for each and every member, and this is separately for the RC basement, wherein we have created, sorry, here we have for the RC members. This is with respect to the footings, and yeah, that is it. So this is basically the bill of material provided by the program for RC as well as steel structures. So everything can be generated at once in MIDAS engines of the solution. So let me go back now to the presentation, wherein I would like to talk about the support services offered by MIDAS. You can study MIDAS engine software solution using the video tutorials available on our website. Lastly, I would like to conclude that MIDAS engine is an all-in-one software solution for structural design, wherein steel, RC, whether it is superstructure or foundation, you can perform a complete analysis, design and drawing, and also generate reports in the form of Word and Excel sheets. You can see there are several methods of modeling depending on the information that you have and the type of structure. There is CAD-based modeling as well for irregular shapes. Then the types of structures that can be modeled, you can see RC structures, steels, and general structures can be analyzed and designed in MIDAS engine. Foundations like strip footings, isolated footing, mat footing, footing girder, pedestal, then basement wall, and piles can also be, pile caps basically can be included for the foundation and substructure design. Then report generation is available in the form of Word files. You get a summary report as well as a detailed design report and a project report generated by the program using Report Maker. When it comes to drawings, we get the design reinforcement detailing and the bar bending schedule for beams as well as for the columns, and we can get the information in the form of drawings for slabs and foundations as well as walls. Then further coming to bill of material, Excel sheet is output is generated by the program for both RC as well as steel members. I'd like to talk about some of our local clients available in Africa, and there are major users. There are some into geotechnical, some are into the structural software, some are into bridge software solutions. This is another list of the local clients. All right, thank you very much for attending this session. I'll be conducting the question and answer session right now. So if you have any questions, please write in the questions box. Okay, Indian standard codes are not included in MIDAS engine. To change the black background, we just have to go to the display tree menu and double click on dark to look at dark black background, and to make it white background, just double click on color style as light. Composite sections cannot be analyzed and designed in MIDAS engine. Timber sections cannot be designed, however, the elastic properties of timber can be included for the analysis. MIDAS Design Plus is not the part of MIDAS engine, it is a separate software solution. In future, MIDAS engine itself is going to include all the design components available in MIDAS Design Plus. So eventually we will have all the component designs in MIDAS engine itself. There are several companies in South Africa as well which are using. If you're interested, we can share you those details. Another question is about how to optimize steel structure with a list of available sections. Well, that part is not yet included in MIDAS engine, and we will be soon coming up with optimization of steel sections with respect to the list provided. Another question is about how can one do ribbed slab design. So ribbed slabs can be created by using slab meshed type of or plate out in type of member, and we can add some beams in between for the ribs, for the purpose of ribs. So it will be manually created and analyzed and designed. Yes, this session is recorded, so we will be sending it to you. Kindly share the details of timber truss. Like I mentioned, what timber truss can be analyzed in the software, not designed. You can analyze using the elastic properties of timber. We will share you the recorded session by your email. MIDAS engine is not linked to MIDAS Design Plus. I would definitely share the details of users in Botswana. All the codes are updated in MIDAS engine software solution. Latest codes are available in MIDAS engine. And if there are any further codes that are going to come in near future, we will be incorporating them as well. Flat slab analysis and design is also available in MIDAS engine software. We have a special member type for the flat slab. So if you can see here, we can create flat slab type of members for the flat slab design. The last 3 sessions that we conducted are also recorded, so we can share it with you. If there are any more questions, please let us know. Yes, I would like to also, I would share the Nigerian users as well. So thank you very much everyone for attending this session.